Hello everyone, welcome to unit number 2. This is population and migration for AP Human Geography, and tonight we are going to be starting with chapter number 2 in the Rubenstein textbook, which is on population. So tonight we're going to be mainly talking about where and how do we evaluate where people are and things like that. So let's go ahead and get started with population agglomerations. Now this is one of our vocabulary terms. And that vocabulary term, the definition is a process involving the clustering or concentrating of people. So really, when we're talking about population agglomerations, we're talking about population concentrations. So people in very close proximity, very close together. And there are 6 different population agglomerations that we want to be familiar with. There's 4 very large ones and 2 that are starting to emerge. So, here's what I would like you guys to do. In addition to underlining your definition, let's go ahead and make sure that we understand the hierarchy that's listed below there. So our top 4 are East Asia, South Asia, Europe, and Southeast Asia. Right? Draw a line there because those are our 4 biggest population concentrations. Then, the 2 that are emerging, the 2 that are growing, and might be on this list in the future, are Northeast North America and West Africa. Now, not only do I want you guys to annotate the list, but let's also annotate the map there to the side. So please go ahead and circle each of those regions. And this is actually something that we will have to do as part of our core map packet here in just a couple of days, and that will turn in the day of the test. That you'll actually have to print this off and circle the population agglomerations. So good practice here. So let's go ahead and circle all 6 of those, and then we'll take a look at each one. So let's get started with our first population agglomeration, and that is East Asia. And the countries that make up the East Asian population agglomeration are China, and really specifically we're talking about Eastern China, the coastal area, Japan, the Korean Peninsula, and Taiwan. Now we'll get into the differences and the specifics of is Taiwan a country and is it part of China. We'll talk about that in our political unit, so that is coming. But for right now, just know that it is part of the East Asian agglomeration. And this particular agglomeration accounts for about 25%, 1/4 of the world's total population. So to give it a rough number, we're going to say 1.5 billion, but honestly that's probably a little bit low. So just know it's about 25%. And it shouldn't come as a surprise to anyone, but the vast majority of that population lives in China. And so since this particular agglomeration is about 50% rural, so 50%, kind of picture living in the countryside. When we say rural, we're talking about living in the countryside. So about half the people in this agglomeration are living in the countryside. Now, most of that rural population is in China because several of the other countries are fairly urbanized. And specifically, we're kind of thinking of Japan and South Korea. Very urbanized, lots of their population living in cities. In fact, I have a statistic for you. About 40% of the population of Japan and the Korean Peninsula are found in just 3 cities. Now, I'm going to tell you what those 3 cities are, but I want to see if you can predict them on your own. So I'm going to give you a moment to maybe think about that. So what 3 cities do you think have the largest populations in Japan and the Korean Peninsula? I've had to do it. Enough people have said that that I'm like Dora the Explorer with the pauses. So I had to throw in Dora there, and I think that's going to be a consistent thing because I think that's funny. All right, back to the question at hand. What are the 3 cities? Those 3 cities are Tokyo, Osaka, and Seoul. Those 3 cities have 40% of the entire population of Japan and the Korean Peninsula. So that's a lot. Again, we're using this to reinforce the divisions within this population agglomeration. China, yes, they have a lot of cities, but they also have a lot of people living in the countryside. Japan, in particular South Korea, are much more urbanized. Our next population agglomeration is South Asia. Now, South Asia is made up of India, Pakistan, Bangladesh, Sri Lanka, and that's where most of the population is. Yes, we could include Nepal, Bhutan as part of this, but as far as population is concerned, we're focusing on the countries where the population is significantly larger. In this case, again, about 25% of the world's people live in this particular population agglomeration. Once again, shouldn't be surprising, most of that 25% is going to be in India, more than 1 billion people there. Right? Now, what's kind of interesting, and we'll give some more details about this later, is that India is currently the second largest country on Earth, the second most populous country on Earth. But very soon, within your guys' lifetime, that will change. And that will be a historic moment as far as human history is concerned, to see that change, because China has been at the top for a long time. And so that will change. Right? Now, this particular agglomeration is about 60% rural. Last one, East Asia, was about 50%. This one is about 60% of the population living in the countryside. Our third population agglomeration is going to be Europe. And this is our third largest population agglomeration, representing about 750 million people. Right? And it should be important, it should be noted that when we're talking about Europe, we're also including the European portion of Russia as well. And usually the Ural Mountains are used as the dividing line between what is considered European Russia and Asian Russia. And that's important to note because a lot of the big cities within Russia, Moscow, St. Petersburg, are on the European side of the Ural Mountains. And so they're included in this population, these population statistics. And the European agglomeration is about 75% urban, meaning only about 25% rural. So this is our most urban of the big four at the top. And really only about 10%, and realistically it's probably less than 10% of the population of Europe identifies as farmers, being part of that primary sector. And so we're not talking about very many people in that particular sector of the economy. Our fourth and final of the big four is Southeast Asia. Now, Southeast Asia is a tricky one, so please put a star next to this and make a note that this is tricky, that this is confusing, because I've seen this throughout the past. Students always get confused with Southeast Asia, where it is, where it is in the hierarchy. So we're going to spend a little extra time making sure we're clear on this. Southeast Asia, to clarify where it is, it's south of China and east of India. So really it's south of the East Asian agglomeration and east of the South Asian agglomeration. So that's Southeast Asia. And so we're talking about countries like Myanmar or Burma, and we'll get into why there's an alternative name there in our political unit. Thailand, Laos, Vietnam, Cambodia, Malaysia, Indonesia, the Philippines, Papua New Guinea as the countries there. And really, there's one area that we should know especially well in Southeast Asia, and that is the island of Java. Now, Java is actually part of the Indonesian archipelago, and it actually contains the Indonesian capital city of Jakarta. And on the island of Java, there are 100 million people. Now, to be clear, this population agglomeration has about 500 million people, so we're talking about 500 million. So 1/5 of that is on one island, the island of Java. So that's pretty significant. And In this case, we're talking a fairly significant percentage of the population. About 66% of this population, 2/3, are rural, living in the countryside, typically associated with the primary sector, farming, and things like that. So here's what I want to do. Real quick, let's reiterate. This is the order from largest to smallest in the Big Four. It goes East Asia and South Asia at the top with about the same. Consider them like 1A and 1B. And then at number 3 is Europe, and number 4 is Southeast Asia. Students in the past have always thought Southeast Asia is the biggest. It's not. It's number 4 out of our largest. Now, I also want us to create a ranking of how urban these populations are, urban versus rural. So number 1, the most urban population is going to be in Europe, followed by East Asia, followed by South Asia, followed by Southeast Asia. And so I do want to point that out. All right, so now let's look at the emerging population agglomerations. And there are 2 that are kind of up and coming. They might be in the top tier soon. They're not quite there yet. They're not quite big enough yet, but they're moving in that direction. So we start with Northeast North America, and really with that we're talking about Northeast United States, Southeast Canada. So we're talking cities like New York, Boston, Philadelphia, probably down to DC, including cities like Toronto and Canada. So we're talking that area. Not quite as significant in terms of population. It's only about 2% of the world's population, but it is the most urban now of the group. All right, when it was just the Big Four, the most urban is Europe. But in this case, the number of farmers in this particular area, less than 2%. Very, very small percentage of people identifying with the primary sector as farmers in this particular concentration. And then we have the West African concentration, which includes, and this is important to note, the south-facing West African coast, as well as Nigeria. Please circle Nigeria, because that's going to be a country that we consistently come back to and we are constantly going to be talking about in this class, along with a number of other countries, but there's certain ones that constantly pop up, and Nigeria is going to be one of them. So a couple of numbers, a couple of statistics as far as Nigeria is concerned when it comes to population. Nigeria is the largest country in this particular concentration, in the West African concentration. It's also the most populous country in all of Africa. It has the most people in all of Africa. And so to give us some context of what that means, there's about 1.2 billion people in Africa. So in all of Africa, there's about as many people as in India or China, give or take a little bit. Out of that, Nigeria is the most populous country. But 1 out of 7 of all Africans are Nigerian. So out of the 60 plus countries in Africa, 1 out of 7 of all Africans identifies as Nigerian. It's that populous. So that is important to note. Now, it is also important to note that this is our most rural agglomeration. So the 2 emerging ones actually end up at 2 ends of our hierarchy. So let's again do our urban to rural hierarchy, but let's add in the 2 emerging ones. So now at the very top, the most urban is going to be Northeast North America. Then we have Europe, East Asia, South Asia, Southeast Asia, and West Africa. That is our urban to rural hierarchy. Please make sure that you know that. All right. And it's also a good practice to kind of think about where we might be going. And so these are 2 areas where we might have new population agglomerations in the future. All right, yeah, we have two that are already emerging, but what comes after that? Because things are going to continue to change. Countries and populations are going to continue to grow. So these are two that maybe we could keep an eye on over the next few decades and see how they are growing, how they continue to grow. So we have the United States West Coast and Highland Mexico as one of those. And then we also have urban South America and the Caribbean. Now, a couple of questions that I want you to think about very quickly. What countries are growing in these regions? Obviously, we explicitly mentioned the United States and Mexico. But like, for example, in South America, what country do you think we would want to keep an eye on as far as population growth and how that might be impacting these population agglomerations? And to change the scale a little bit, what cities do you think we should maybe keep an eye on? Because I think there are a few that perhaps come to mind. Los Angeles, Mexico City, Rio de Janeiro, Sao Paulo. These are several of the cities that I think come to mind in terms of very large populations and in terms of population growth as well. So something to think about. This is just an additional article for you. It talks about India's population. The title is actually, India will be the most populous country sooner than thought, the UN says. So some statistics from the article in case you don't get a chance to read it. The UN estimates that it will be the year 2022 when India becomes the most populous country on Earth. 2022 is when that is expected to change. In addition to that, they give us some context about global population numbers as well. The UN predicts that by the year 2050, so the mid-century point, global population will increase about another 2.5 billion people from now. And their numbers are 9.76 billion by 2050. They also project out to 2100, the beginning of the new century. And the UN predicts that at the beginning of the new century, 2100, global population will be 11.26 billion people. So the question that we have here, and this will be a question that we address in class and in future lectures, is can the world sustain that? And as always, the answer may not be as black and white as we think. Shifting gears a little bit, let's talk about the difference between why people are where they are. And so we introduce another vocabulary term. This is ecumen. The ecumen regions of the world are the portion of Earth's surface occupied by permanent human settlement. And that's about 80% of the world's landmass. Now, because we have areas that are occupied by permanent human settlement, that must also mean that we have areas that aren't. And those areas we are going to call non-ecumen. Now, that's not a very technical term. We're just saying that it's the area that isn't occupied. And so we're going to classify these areas as too harsh for permanent settlement. And there's actually 4 different designations as to why there aren't people there. Now, to be very clear, there's people just about everywhere on Earth. There's a lot of people that are living in that 20% that's not considered part of the ecumen. It's just not a huge number of people compared with what we see in the ecumen. There are people that live in the non-ecumen zones. It's just not a lot of people. Right? So, for each of these areas, I want you to think of an example. Right? For each of the non-ecumen zones, think of an example of a place where there aren't a lot of people living. So the first one that we have there is areas that are too wet, too much water. And what immediately jumps to mind are areas like oceans. But also, consider places like swamps, the Everglades might be a good example. Next one are areas that are too cold. Antarctica comes to mind. The next one are going to be areas that are too high, elevation too high. And those are going to be, your mountaintops, things like that. So I think of the Himalayas, I think of the Andes, places like that. And then finally, this is the one that has been confusing for students in the past, are areas that are too dry. Now, what do we mean when we say an area is too dry? And hopefully you said that there's a lack of rainfall, lack of moisture. So we have areas that are too wet. We also have areas that aren't wet enough. And so these are areas that get too little precipitation. Now, the one thing where students have been confused is I hear a lot of students say it's too hot. Not necessarily, because Antarctica is technically a desert based on the amount of precipitation and rainfall that it gets. Now, most of that rainfall falls as snow, but it's still considered a desert because it doesn't get very much precipitation. Right? So, to be very clear, too dry means a lack of precipitation, a lack of water. And so I tend to think of the Sahara as an example. The Sahara Desert. So now let's take a look at where this is. Where are the Ecumen versus non-Ecumen zones? And so we'll look at change over time. And we'll start out with about 7,000 years ago, 5,000 BCE. And the areas that you're seeing there in yellow are areas where hunting and gathering was taking place, where people weren't permanently settled. And so the areas in green are part of the Ecumen. So over the next 3 maps, I want you to watch the expansion of those green areas. Fast forward 5,000 years to the BCE CE changeover, and we can see the expansion of permanent human settlement. Now fast forward just 1,500 years, it expands further. So we're expanding the Ecumen zones. And now our most recent map looks at the Ecumen zones now, and that's that 80% that we see in green, right? The 20% being the yellow or the white, areas that aren't permanently settled. There are still people there, but we don't see permanent settlements. And in fact, that last map in the bottom right there is one that you will use in your study guide packet, Key Issue 2.1, question 4B, where you have to annotate the map, and it's actually in your map packet where you'll be annotating it. But you'll use that bottom right map in order to help annotate it and label it. Shifting gears again, now we are talking about measuring population. And so now we're going to look at population density. And when we say density, let's review what density means. It was one of our vocabulary unit words last unit. Density is the frequency of something in a given area. So in this case, we're talking about the frequency of population. So all 3 of these measure the number of people in a given area of land. People to land. And they measure different groups of people, they measure different kinds of land. But just understand what we're talking about here when we say density. We're counting the number of people in a given area of land. And there's 3 different ways to measure that: arithmetic, physiological, and agricultural. So let's start out with arithmetic. Arithmetic density is defined as the total number of people divided by the total land area. So that's total number of people divided by total land. And I would encourage you to write that formula, people over land, so that you have that shorthand and maybe make it a little bit easier to remember. Now, to be clear, arithmetic density, you might actually see it by a couple different names. So I want you guys to be aware of that, be ready for that. You may also see it as just crude population density or crude density. You may just see it as plain population density. And typically when somebody starts talking about population density, they're talking about arithmetic density. They're talking about the number of people compared to the total land area in a given place. Now, on the positive sides, this is really easy to calculate because those numbers are readily available. It's just total number of people divided by total land area. On the negative side, though, it doesn't really explain why it is what it is. It tells us where, it doesn't really tell us why. So, on this next slide, what we see is the spatial representation of arithmetic density. So let's ask our usual questions. What type of map are we looking at? At what scale are we analyzing this? And I'm going to throw in a third one for you. Is arithmetic density a good indicator of development? As always, whenever we ask those questions, please make sure that you include your answers in your notes. What type of map? This is a choropleth map. At what scale are we analyzing this? We're analyzing it at the national scale. And does it appear to be a good indicator of development? And I would say no. There's not a clear divide between more developed countries and less developed countries. In other words, more developed countries don't necessarily have a higher or lower density, and vice versa, less developed countries don't necessarily have more or less, higher or lower. But let's go ahead and focus on one country so we can change the scale and see how this goes. The United States is in the class, and this is a choropleth map, so a bit of an issue with this. We just know that it is below 50 people per square kilometer. We don't know the actual number. I'll give you the actual number here in a few minutes. We just know that it's under 50. Now, do you think it's under 50 everywhere in the United States? Well, let's check. So once again, let's ask the questions. What type of map are we looking at? At what scale are we analyzing this map? And we see it as, once again, a choropleth map, this time at the county scale. Again, it's not subnational. We can see within the states the divisions that exist there. Noticing in Nevada, you can see Clark County, you can see Washoe County. So you can see those differences there. That tells us that it's at the county level. Now this is a choropleth map. Is it a perfect choropleth map though? Because there's 7 classes here. And there are some issues as far as how easy it is to read. All right, but it's pretty good. It's very accurate. It definitely comes from a reputable source from the Census Bureau. So let's point out a couple of things here. The red dot that you can see there in the middle of the map, or close to the middle of the map, down at the bottom, that is the key for the geographic center of our population. So the geographic center of our population is located in Missouri right now. And that is something that has been calculated with every census, every 10 years, ever since 1790 with our first census. And consistently, every single census since 1790, that geographic center of the population has moved westward. And it continues to move westward. So it won't always remain in Missouri, and it'll be interesting to track that. The next thing that I want to ask you is, can you see the areas within states, even though it's at the county level, can you see the areas where our big cities are? Can you see where Seattle is? Can you see Los Angeles, Las Vegas, Salt Lake City, Phoenix, Denver, Dallas? Can you see Chicago? Can you see Detroit? Can you see New York? Can you see Miami, Atlanta? Hopefully you can. All right. Take a look, see if you can pinpoint where some of those places are. Now, one last thing I want to point out before I cut you guys loose to make your observations is, again, in the bottom left-hand corner next to the key, it tells us a little bit more information, because it tells us that the average population density, that is people per square mile on this particular map, is 88.4. So there's 88.4 people per square mile in the United States is the average. Now, to be clear, on the last map, it was people per square kilometer, so a different unit of measure there, which is why we were in the less than 50 people per square kilometer class. So, as we can see here, it obviously varies across different areas. It varies across the state of Nevada. It varies across the country. So now I want to cut you guys loose. What observations do you notice about this? I pointed out a couple things, but I want to give you a second. What do you notice? Moving on. Our next few maps are going to go kind of quick, and I just want you to make some observations about these. Somebody took population data and applied it so that we have a better understanding, some more context to this. So this first map, at the top it says there are more people in the red regions than in all the gray combined. And that hopefully shouldn't be a super big surprise to us when you look at the countries that are in red. You've got China, you've got India, you've got Indonesia, you've got Japan, South Korea, Bangladesh, all part of that red region. Countries that we know have very big populations. Now, what you're going to see over the next few slides is a comparison of population density and total global population. So for example, getting us started here, it says if everyone lived as densely as they do in Manila, which is the capital of the Philippines, the entire human race could fit into Tunisia, which is a country in North Africa. Now, a little bit of background about Manila. Manila is the most densely populated city on Earth. One statistic that I've seen puts it at 41,515 people per square kilometer. 41,000 people per square kilometer in Manila. To juxtapose that, the US was in the class of 50 people per square kilometer. Less than 50 people. And there are 41,515 people per square kilometer in Manila. Now, those numbers can vary depending on the source, and we're going to talk about why that is as the year goes on, right? But if there were 41,515 people for every square kilometer, you could fit all 7.2 billion people on Earth in Tunisia, in North Africa. To continue this trend, let's use some other examples. In Manhattan, population density in Manhattan in New York City, that's about 25,000 people per square kilometer. And if everyone lived on Earth, 25,000 people per square kilometer, all 7 billion of us could fit into New Zealand. Mumbai is 20,000 per square kilometer. Everyone could fit into Germany. Bangladesh, 1,236 people per square kilometer in the country of Bangladesh. Everyone would be able to fit into Australia. South Korea, New Jersey, about 500 people per square kilometer. Everyone would fit into Russia, all 7 billion of us. Now, changing the scale a little bit. Okay? It says the population of Yemen is the same as the average across Earth, meaning that population density in the country of Yemen is about the same as the global average. And the global number is about 56.63 people per square kilometer. 56.63 people per square kilometer is the global number. Now again, we can continue this practice. The US, we were in the below 50 class. Ours is about 35. 35 people per square kilometer. If all 7 billion people lived at 35 people per square kilometer, we need 1.5 Earths in order for our entire population of the world. Continuing that, if everyone lived as they do in Brazil, that's 24 people per square kilometer. We need 2.25 Earths. Continuing further, Canada, 3.9 people per square kilometer. You need 14 Earths. Are we going to stop there? Of course not. Wyoming, 5.1 people per square kilometer. You need 23 Earths. And Alaska, 1.1 people per square kilometer. That is one person for every square kilometer. You need 100 Earths to fit all 108 Earths in order to fit all 7 billion of us. So just having a little bit of fun with that before we continue on to physiological density. And that is physiological density, the number of people per unit of area of arable land, land that is suitable for agriculture. So to create that abbreviated formula, we're talking total number of people divided by farmland. Total people divided by farmland. Now, on the plus side, this is a little bit more meaningful because that's the land that's going to grow the food for those people. So how many people do you have? How much land do you have to grow food for them? And if your number is low, then you have either low population or you might have more land in order to feed those people. Now, if you have a high physiological density, that means there's a lot of pressure on that land. Either you don't have very much land or you have a very large population, or both. And so that's something that isn't necessarily a bad thing, but it is something to keep an eye on. Because if some kind of natural disaster happens, if the rains don't come, a famine, a drought, to where that land isn't as productive as it normally is, people may die. So, let's take a look at physiological density. So let's ask the questions we've been asking. What type of map are we looking at? It's choropleth. What scale? National scale. Is this a good indicator of development? I wouldn't say so. There's not that clear divide between MDC and LDC. But again, let's take a look at the United States. What would happen if we changed the scale for us? Would every place in the United States be below 250 people per square kilometer of arable land? That's farmland. Would it be that low all across the U.S.? What do you think it might be for Nevada? Think about Nevada. How many people do we have? How much farmland do we have? What might it be in Iowa? What might it be in Florida? So again, we don't necessarily have to know the answers to these questions, but just thinking in that direction is going to be important. The last of our three types of population density is agricultural density. And that is the ratio of the number of farmers to the total amount of land suitable for agriculture. That's arable land. So to complete our abridged formula, we're going to say that is farmers over farmland. Farmers over farmland. So to review, arithmetic density is just people over land. Physiological density is people over farmland. Agricultural density is farmers over farmland. And in this case, we have some other factors that we have to take into consideration. And those are level of development and the type of farming. So I want to ask you a question. Which is going to have more farmers? MDCs or LDCs? Remember what we talked about with development. Which one are we going to see having a bigger stake in the primary sector? MDCs or LDCs? And then, why? Think about that for a second. Last Dora moment of the night, I promise. Hopefully you said LDCs are going to have more farmers. All right? They have a bigger percentage of their population engaged in the primary sector. And now we have to ask why. Why are MDCs going to have fewer farmers? And it's because of level of development. So let's take a look at the map. Once again, let's ask the questions. What type of map are we looking at? What scale are we analyzing? And is this a good indicator of development? And we've got a choropleth map, national scale, and I would say yes. It's at least a better indicator of development than arithmetic or physiological density. Because the number of farmers is based on a couple of things: level of development and the type of farming. Because if you're an MDC country, do you need to do a lot of that work by hand? A lot of the farmers that we're going to see in MDC countries are going to be using a lot more machinery. You don't need as many workers because you have huge machines that are going to do a lot of that. And so this is going to be an interesting conversation where we can juxtapose commercial farming versus subsistence, and something that we will talk about in the future. And that's where type of farming comes in, because something like intensive wet rice farming, what we see in parts of southern China, coastal India, much of Southeast Asia, requires a lot of work. It's very labor intensive. Whereas something like nomadic herding, ranching, it doesn't require as much work. You don't need as many farmers in order to get the maximum output. So those two things have an impact on agricultural density. So please make that note. Finally, let's look at the impacts of our different types of population density. So the first one that we have to talk about is carrying capacity. It's one of our definitions, and that is the population level that can be supported given the quantity of food, habitat, water, and other life infrastructure present. So how many people can you support? And the interesting question with this is you can change the scale on this. How many people can a city support? How many people can a country support? How many people can the planet support? Given the quantity of food, habitat, water, and other life infrastructure. And so you have to look at a couple things like, do you have enough jobs? Is there enough housing? Can your transportation infrastructure withstand the population pressures of that area? The number of people within that area, right? And so the example that I want to throw out to you is this. The city of Tokyo is the largest city in the world at about 38 million people, depending on the source and depending on the boundaries that you draw. But the greater Tokyo metropolitan area is about 38 million people. That's roughly the population of the state of California, living in an area about the size of Los Angeles. LA has about 12 million people. Do you think LA could handle, given the infrastructure, the food, all these different types of things, do you think LA could handle 3 times as many people? 12 million up to 36 million. That's what we're talking about here. The impact of that. And so the way that Tokyo is set up and life in Tokyo is going to be a little bit different based on that. And so we have to understand that. Now, taking this to another element, as far as politics go, especially here in the United States when we talk about redistricting and legislative districts and things like that, we're going to see that redistricting after the census, those districts have to be about the same population. So population density is going to factor in there. And the redrawing of those legislative lines are going to be an element of that. I know that this lecture has been going on for a while, but one last resource, if you would like to take a look at it, is an article called Vertical Villages Are Changing the Concept of Neighborhoods. And it looks into this concept of a vertical village, which is really just condominium high-rises in cities. And it means that more people can live in a smaller area because you are growing up instead of out. And it's a really interesting article, but it really does kind of challenge, especially the way of life that we have seen here in the United States, where we've seen a lot more outward growth than upward growth. And so I always like to ask students, which would you prefer? The space of the suburbs or the interconnectedness, and this is something they talk about in the article, the interconnectedness of an urban condominium. All right, being in close proximity with the people around you, being connected with them in that way. Or would you rather have the space, big backyard, hey, streets to play in, all that kind of stuff. And so it's kind of an interesting idea just to leave off on with this. And so I will leave you guys with that. I know that this was a long lecture, but thank you so much for your attention, and we'll see you in class.